Hi guys, it's Miss Liguori. I hope you're doing well. Today I am here because I want to show you the differences between a linear, quadratic, and exponential function table. So as you see on my left, we have linear, in the middle we have quadratic, and on the right we have exponential. So you now should know what these functions look like as graphs. Okay, so now we have to be able to identify them from tables. All right, so let's look at the linear one first. All right, I have some notes here. Okay, linear, you're never going to see the same y value twice, right? If we did, then that would mean it's looping around. It's not a straight line. Okay, and then how you're going to tell it's linear is that it's going to have the same difference every single time. All right, so what that means is when I look at that y value, because that's really all that matters, okay, I'm looking between here. And I'm trying to find a pattern. So if I think about from -1 to 1, well, 0, 1, that's going up by 2. Then I think about 1 to 3, that's also going up by 2. And then from 3 to 5, it's also going up by 2. So this is linear because it has a common difference of +2. So linear we could either add or subtract. Okay, so add plus or minus. And as long as it's the same number over and over again, it's going to be linear. Okay, let me change the color. All right, I'm actually going to go over to exponential over here because exponential is also easy, just like linear is. So again, we're only looking at the y value. The y value is never going to be seen like twice. However, there's going to be multiplication. Okay, so we could see multiplication or we could see division. Okay, so linear, here it was either adding or subtracting. If it adds or subtracts by the same number every time, it's linear. Over here, it's going to be if it multiplies or divides by the same number, it's going to be exponential. So if I look, so even if I was just doing this and I was saying adding, okay, so here this is +1, and then right here this is +2. So automatically I know it's not linear because these numbers aren't the same. So I'm going to erase that because I know it's not going to be adding. So now I try multiplication, right? So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So now we see again the same pattern, the same thing happening every time, except we're just multiplying. So that is what we would call exponential. All right, so our last one is quadratic. Now, you can see the same number more than once when we're looking at the y. Now remember, a quadratic looks like a parabola. So when it's saying the same y, yeah, there could be 2 points that are the same, and that's okay when it comes to the graph. So that's why we say see same y more than once. That's all right. And if you notice here, there is a +1 here, and then there's also a +1 here. Okay, so this is where it gets a little different. Okay, so this is going to be the second difference. Okay, so I'm going to look at this, and I'm going to notice that from 1 to 0, that's -1. And then from 0 to 1, that would be a +1. Okay, and then from 1 to 4, that's a +3. And from 4 to 9, that's a +5. So obviously this is clearly not linear because we are not adding or subtracting by the same numbers. All right. Also, if I went through here and I tried to decide what could be multiplied, well, 1 times 0 would be 0, but then 0 times nothing would give us 1. right? And then 1 times 4 would be 4, but 4 times 4 is 16, not 9. So there's no add, we're not adding, we're not subtracting by the same thing, we're not multiplying, we're not dividing by the same thing. So automatically, if you see that, you can kind of assume that it's going to be quadratic. However, we do want to take one more step to just prove that this is correct. And that's where this says the second difference is the same. Okay, so I found the first differences. Those weren't the same. But now, let me just change my color. If I say from -1 to 1, what's the difference? Well, that's +2. And then from 1 to 3, that's also +2. And then from 3 to 5, that's also +2. So that second round of differences ended up being the same. So that's how I can tell it's definitely quadratic. Now we could assume that it was quadratic because right here there was no same rate and there was no same ratio. So that is just a few different ways. All right, so I'm just going to do 2 more examples just so we get a little better at this. All right, so we're going to look at this first top table. I got my x values. Now remember your x, it doesn't really matter, right? We're just looking at our y's. So automatically, I start with linear. We just go ahead and think linear. All right, is the y value adding or subtracting anything the same? So I say, all right, well, from -2 to +1, that would be a +3. And then from 1 to 4, that would also be a +3. 4 to 7 is a +3. And 7 to 10 is a +3. Awesome. I added all the same things, so this is definitely linear. I don't even need to go and check the multiplication, the second difference. I don't have to do that because right away it's linear. Okay, so if we were to write a function for this, we'd say this is y equals 3x, and then the initial value was 4, so we'd say +4. Okay, and that's our y equals mx plus b. Now you don't need to do this yet right in the equation, but I figured might as well. All right, so our last example down here. All right, we're going to determine is it linear, exponential, or quadratic. Okay, so again, we're not going to really be looking at the x's. We're just focusing on the y. So now if you notice, we have some decimals. Now, if you're not the best with decimals or the best with fractions, my suggestion to you is to go over here to the whole numbers, maybe find a pattern, and then make sure, see if it works with the decimals as well. All right, so if I look at this 2 to a 10 and I was to add, I would say, well, that's +8, but then from 10 to 50, that's +40. Okay, so this is clearly not linear because we're not adding by the same thing, so I'm just going to get rid of that. Okay, however, before I think quadratic, let me think, is there anything I can multiply by? So 2 times 5 would be 10, and then 10 times 5 is 50. So automatically, so I see I have 2. So now I pull up my calculator and I'm like, all right, let me see, what's 0.08 times 5? Now I know you guys can't see my calculator, but 0.08 times 5 is 0.4. And then 0.4 times 5 is also 2. So in this case, we have a common ratio, which means this is exponential. Okay. So that is that. So if I wanted to write the equation for that, we would say y equals, the initial is where it was at 2 times 5 to the power of x. Okay. Hopefully that makes sense, a little bit more sense. If you already got it and you just watched this for another reclarification, awesome job. Thanks.